my name is Simon, also known as Polyhop. Today we're going to talk about easing in TouchDesigner, specifically what it is, why it's useful, and how you might use it in your projects. We'll look at the core basics, followed by a walkthrough of an example project, and then lastly I'll demo a tool that I've created that makes it a bit faster to play with different easing curves. The tool and the project example are both available on my Patreon. And speaking of which, thank you to all my Patreon supporters. And I want to give a special thanks to my top supporters for supporting this. So here's a site called easings.net. And I came across this relatively recently, which sort of inspired some of the work that I've put together here. And it's a nice open source website that has a variety of easing functions. Now, easing functions, as they say here, are functions that specify the rate of change of a parameter over time. So objects in real life don't start and stop instantly and almost never move at a constant or linear speed. So this is a kind of like a resource where we could hover over these different functions and see on the right, that little cursor that bobs up and down, how this motion would look when you're driving it with a linear source. And additionally, if we clicked on any of these, it does give us more information and even math functions that you could use in TypeScript, but generally speaking, this logic could be adapted to other languages. There's a lot of information and tutorials out there for easing, primarily in the context of motion graphics and animation. I'm going to be looking at how we can use easing specifically in TouchDesigner. So a little disclaimer here regarding the way I use the terms ease in and ease out in this video. Only after recording, I thought to check that I was using the terms consistently, and of course then I found there are possibly two ways of using the terms, sort of depending on if you're coming from animation or from a developer background. So I'm basing this on a little article by Nathan Gordon that I found linked in the description. And the first way that easing might be used is how it's presented in Disney's 12 Basic Principles of Animation. So in this case, we think about easing in and out of a value, which in traditional animation would be a pose or a keyframe. And the alternative, as often used by developers, would be to actually describe the curve itself. So if the ease is happening at the beginning of the curve, then it's an ease in animation, even though in the context of animation, we'd be easing out of that value. So you can see how it's opposite depending on the context of what you're applying the easing to. So I learned it myself in the context of keyframing and animation, not coding. So for the most part, that's how I use the words. I'll say easing out of a value or easing in to a value. Now, hopefully I'm consistent, but I might not be 100%. So if I make a mistake, I still hope you get the gist of at least how you can apply these curves. Using easing in TouchDesigner for animating can be incredibly powerful and add a lot of nuance to the motion of your work. Here's an example that I made at the beginning of this year during January, which is a generative art month, where each day is a different prompt, and the prompt for this was loading bar. And I made pretty heavy use of a lot of those functions from easings.net that I ported to TouchDesigner, specifically for the way that the claw moves, the way that the boxes kind of scrunch, and even the bobbing of the text back and forth when each box is placed down. So essentially, everything starts linear, and then it's translated to one of these more nuanced motion curves at some point in the pipeline. All right, so let's look at how we can do easing in TouchDesigner, and specifically kind of a very basic example looking at chops. On the right, I've put together a visualizer that shows our initial curve and our final eased curve. Currently they're the same, so we're seeing the motion identically, but as we make changes to our eased value, we'll see the white dot change in its motion in comparison to the source. Now, this is being driven by a triangle wave on an LFO chop, and I have a offset of 0.5 and an amplitude of 0.5, so we're going from 0 to 1 and then back again. To add some easing to this, I'll want to use the lookup chop. I'll say this is perhaps one of my kind of like MVP operators, and that also includes the lookup top. I use them all the time for motion as well as things like color and other times when I want to take, say, a linear range and remap it to a curve or another set of values. And in this instance, we can use the S-curve chop. So this is a great way to just get a quick easing curve that eases out and then in to our target value. So you'll notice the way that it already affects the motion. So it's a lot smoother as it approaches 1 or 0. We might also want to add a little bit of padding just so we can kind of see what would happen if it stayed at 0 or 1. I could do this here with the prepend and append, though I want to keep the linear motion. I also want to include that same shape, so I'll just copy this S-curve and fully linearize it. So you'll notice this just gives me a linear ramp, but it has the option to add, say, 100 samples to the start and end. So now we pause at each side. And in addition to those prepend and append options, we also have a steepness parameter, which is great for if you want something to move faster between two values. Additionally, if we wanted it to only kind of ease in or ease out from our value, then we can bring linearize up to 1 and adjust the bias to get strictly ease in or ease out curves. We also have some other options for curve type. So I actually don't use these that often, but I should maybe more. They're interesting. You get the logistic curve, which has a quick, like a steep incline, and you spend more time at the start and the end, almost like if you had a prepend and append included. Though there's a little bit of motion, which is nice. And then the arctangent is somewhere in between, where we still have quite a steep transition, but a longer like period where it's kind of slowly moving to that motion. So I think all three of those are definitely things you can play with when you're controlling motion of, say, an instancing network or even just simple UI elements. The other operator I want to point out here is the trigger chop. So you might be familiar with it in this mode where it gives you a time slice, an attack, decay, sustain, release. And you could even use this to drive, an easing function. Say if you went in here and changed it to linear, then you'd be able to, click pulse and you could make this move based on some other input, whether it's driving this source or even just clicking a button. Though it also has an option to turn off time slice, and now it gives you basically a channel here that shows your attack, sustain, decay, release. And so that's pretty great since we can now use this with our lookup chop. So what we want to do, since we are looking to transition between 0 and 1, we want to keep the start and the end values the same. We can go ahead and just remove this release completely, bring the release length down to 0. And I might use this to create sort of a curve that goes a little bit past its goal and then kind of dips back down to 1. So I'll actually set my sustain level to 1 and increase the peak level, say to 1.1 for now, and then bring the peak length down to 0. Now, this is 25 samples, and so if we plug this in, it should actually still be moving pretty smoothly, though that is because we have interpolate on. So you'll notice if I turn it off, you can actually see what resolution we're actually sending it. So to give it a little bit more control, we can change this to samples, and we can see, okay, we only have 12 samples for our tack length. So let me make that something larger, like 800. And then for our sustain, similarly change this to samples and maybe 100. Let's see how that looks. Maybe a little bit bigger. Yeah, so we kind of want it to jump past, and we can adjust the peak level now and try to get something that looks good. So there we go. Yeah, it's starting to look better, and I can even turn on interpolate. Usually I'll leave that on unless there's certainly instances where I don't want this on, but in this instance, it gives us a smoother lookup. So here's a relatively straightforward example that uses a bit of easing and also makes use of various lookup chops and tops throughout. So I'm going to just kind of in broad strokes talk about the process that's happening here. So first off, we have our instancing setup. There's a source grid that's being used to generate, eventually going from sops to chops to tops. We can see that I'm selecting that over to the right. So first off, right here I have my initial position, and that's being used. We're adding noise to that to displace it. You can see that happening here. And then eventually we're blending those two together using a matte top. So that's a useful way to essentially take two different inputs, and using the third input, we can blend between them on a pixel to pixel basis. We're also adding a little bit of rotation. It's pretty subtle, but that's happening only when we're in the displaced state. So here I'm also using my initial position to keep this size the same. And then, you'll notice it's a little bit higher amplitude for the rotation. We're also essentially like masking it or multiplying those rotation values by 0. So this is pulling, we'll look at the actual curve that's driving this animation in a moment, but this is basically being used to multiply those values when I don't want my boxes to rotate. So in this top left, here is our looping logic. So you'll notice that if I move the timeline, this is all synced to it, and it should loop perfectly. So I've talked about this a bit in my looping noise tutorials, but we take the timeline, the current frame, and the end and divide them to get the fraction. I'm also multiplying this by 3. So you'll notice that there are 3 passes that this takes as it goes throughout the timeline. So I do limit that by looping it with a limit chop so that we have a fraction that goes from 0 to 1, but I also take the floor of that same value, so that gives me like which cycle we're currently on, and I can use that value to drive our noise period. So each time we see it, of those 3, we have a slightly different variation of noise displacement. And you might recognize this from those looping noise tutorials, but essentially using our fraction with a lookup chop to get a sine and a cosine wave, and that can be used to translate the TZ and translate 4D parameters on both, in this instance, it's both our rotation and our position noise. I'm also rotating the camera based on this fraction. We're only rotating the camera by 90 degrees, though I'll note that this only works when our render looks identical at a rotation of 90 degrees. So in this instance, not only does our initial grid need to have rotational symmetry. We need to make sure that it is in that initial position at the start and end of the timeline. So in the bottom left here, in these blue annotate sections, this is where I'm kind of doing first like generating my animation curve, which is linear, and then eventually using lookup tables to add some easing functions. So I start by creating some mono noise. Now this is essentially staggering our animation per instance. So if I actually set this to 1 with a constant top, so let's just put one of these in here and make it just set resolution only. What you'll see now is all of our boxes move at the same time. This can be sometimes desired, though I think there is something dynamic when we stagger the motion of each box. This initial value doesn't need to be noise, however. For example, we can swap it out with a ramp top. So here it will kind of move from one side to the other. Or for instance, we could change this to radial or circular, actually. And so now we'll see it move from inside out and then back again. We'll keep it on noise. That's what the example looks like. And so we're using this as the initial sort of values. I'm also clamping this from 0 to 1. And then I take this triangle wave as a chop. And again, I'm pulling from the fraction that we've established here that loops 3 times throughout the timeline. And using a lookup chop, I get this value that goes from 1 to -1 to 1 within one fraction. So I'm adding this to my values so that because these go from 0 to 1, now my values will eventually go, from roughly, shifting all of them by 2 totally. And if I limit that, clamping it at 0 to 1, we'll have all the values slowly shift from white and then down to black, or from 0 to 1, and kind of, oscillating between those two values. But the goal is for it to be entirely black at one point at the bottom of the curve and entirely white at the top of the curve. Next, we have a little bit of padding. This is determining how long it stays in the on or the off state, or the 0 and the 1 state. So by adding, I'm actually doing this with a ramp, but you could definitely do this with a S-curve chop as well. And I've set this to linear, and I've just added a little bit of space on either side. So this is essentially the ratio of how much is it staying at those targets and how much is it moving over the course of my fraction. So, yep, that's my curve. And then I want this to move differently when it's moving out versus in. So first I am just using that same linear curve with 2 different lookup functions. So the first one, I'm just using a really standard S-curve. And this is just a different example. So instead of using, say, we could do this with a ramp as well, but you can also just feed that right into the as chop values. So this is another way we can use the lookup top and directly drive it with a chop curve. So here we can adjust things like the steepness if we want it to flex faster. We won't see it for a second. So this is a way you can kind of play with motion. Or if we want it to move slower, we would, bring that down, or not as rapidly. Below, we have a port of the bounce out curve from easings.net in a GLSL top. I won't be going into full detail in this video about the process, but it is included in the project example, and the full set of easing.net curves are included in my TDEase tool that we'll look at a bit later. Now, I have both of these, and if I actually, removed this switch here and just pulled in one of them, you'll see that now I only have my S-curve motion. And likewise, if I pulled in this one, we should see it bounce up as well as down. So really what this does is I need to be strategic about exactly when I switch between these. If this happens at the wrong time, you will get a discontinuity. All the boxes will jump because if I pause it, these values are not the same. But at the top and the bottom of this transition, right at 0 and 1, these should both be essentially 1 and then both be 0. So I'd need to make sure I'm pulling on that same fraction and then using a logic chop saying, okay, when the bounds are between 0.5 and 1, so when I know that I'm at the, has to match my pattern. So when I'm in the upper portion of this curve, I want to flip to the corresponding easing function and vice versa for the lower portion, flipping the switch to select either the motion in or motion out. Just a way I can flip between different motion curves without seeing that discontinuity. As long as these values are the same, it should be seamless. And then lastly, those values are what we are feeding our matte top with. This could be luminance, red, green, blue. It's really all the same because in this instance, those values should be identical, except for alpha. And so, yeah, I didn't mention this before, but I am using this circle as a mask. So this is, in our instancing, connected to our active for the alpha. I did also want to mention, if you want, you can certainly use the animation comp actually as a way to draw your own lookup curves. So this is something that you may not know. Under play mode, we can choose output full range. And if you say want to edit a curve, you can go ahead and do that in the animation editor. And then this will output the curve instead of an animation that's locked to the timeline. So this can be used in tandem with, say, the lookup chop. And it can be a nice way if you do want something precise that you're having trouble defining with, say, like pattern chops or masks. The last thing that's happening here, we sort of looked a little bit at this instancing here, so this is pretty standard, and then we are using a PBR material and a pretty standard rendering network. I won't go too deep into that. So inspired by that easings.net website and also just my general need for easing functions in TouchDesigner, I built this little tool called TDEase that takes both chop and top inputs and applies easing curves to them. Now I've included all of those functions from easings.net and then included a few additional ones that aren't really easing functions. They're more like processed impulses. And these are from Inigo Quilez, who's a pretty well-known contributor to graphics research and definitely an all-around shader wizard. So these are currently all of the ones that are included, though I'll also, on my Patreon, have a little bit more of a video that talks about how you can extend or modify these. There's a view here that lets you see, now in addition to the curve, you can see the chop out and the top out. So it serves also as just a viewport if you're not wanting to just see the curve. And then on the left, we can choose these different functions. So something like the back ease in out that overshoots its target a little bit. I think the other ones that I find pretty kind of unique, things like the bounce ease in, ease out, which give you this bouncing motion. Now, this is not like a physics simulation, right? But it's definitely a lot easier than trying to incorporate something like that into a system when you might just want to drive it with a linear ramp. Similarly, this elastic ease in, elastic ease out gives you this little wobble that I think feels pretty nice. So I've definitely used that in a few different instances where I want that motion. A lot of these are also just your standard kind of different degrees of S-curve. And so kind of in these instances, you could accomplish this with your S-curve chop or with a ramp top, though I'll also note that I do find myself grabbing this quite a lot because it does put together all of those pieces, already. So it is definitely a handy tool, even when you're just wanting to use, be able to swap between a couple pre-made, S-curves, or, you might try the S-curve, try the back out. You can sort of quickly compare how that affects your system without having to sort of swap out your S-curves or your inputs. If you're interested in this tool or the project file for the previous example, they're both available over on my Patreon. And either way, I hope this provided some insight into how easing can be used in your own TouchDesigner projects. So thanks for watching.